Greetings, everyone, through here. Welcome to another exciting episode of the Demo Hub. Today, we have a very exciting guest coming from SQL DBM. Serge Geshkovich is joining us. Serge is Product Success Lead at SQL DBM, and will be talking to us today about SQL DBM and the role within the modern data space. Serge, welcome to the show.
Thanks. It's really great to be here. It's a pleasure.
Very glad to have you. Where are you calling from?
From Spain. So the accent betrays me a little bit. So I'm not actually from here. I'm from the States, but I've been living in Spain for about the last decade. So it's a unique but interesting place.
Oh, nice. I've always had on my bucket list to make it out to Spain. Just haven't done it yet. Maybe
Okay.
sometime.
Well, now you know who to call.
There you go. Excellent. So, Serge, can you talk a little bit about SQL DBM? Just introduce that for the audience who don't know. I'm hoping there's not a lot of people who don't know what SQL DBM, but just touch a little bit about what the product is and what you do in the market.
Sure. Yeah, thankfully, we're seeing less and less people who are unfamiliar with modeling in general, but with us as a tool in the growing modern data stack. So we are the only cloud-based database modeling tool out there that supports native data cloud platforms like Snowflake. It's really the same old modeling that has been performed on databases since databases were invented in the 70s, but just streamlined a little bit to run in the cloud, be completely native, easy to share, easy to integrate, one-click add. And it really highlights more the collaboration side in modeling than just the old school kind of modeling concepts of keys and constraints and ER diagrams, because all that is great. We're big fans of doing proper modeling, but it can't live in a bubble. It needs to be shared with the organization. That's where you really derive the value of, a data model is no good sitting in somebody's drawer, printed out on a piece of paper. It needs to be accessible, and more than just accessible, understandable. So it's great to have all the bells and whistles for the architects, but also needs to be something flexible that you can flip it in the click of a button and present it to a business user and have them make sense of it and make sense of their database.
Exactly. Maybe we double click on that a little bit because, my background is on enterprise architecture. And part of that was talking about modeling the business and the technology from different perspectives. Database modeling, who typically is the audience? When should the organizations think about not just doing things in spreadsheets to going out and getting a robust data modeling tool like SQL or DBM?
That's a great question. So our audience, I hate to say it, is everyone. So we're an enterprise tool. So we see everyone from big enterprise size companies with hundreds of users to startups with 2 or 3 data architects, and they don't have even much of a user base yet. And in that regard, it's really, you see both the good and the bad. So obviously, if you're doing some kind of modeling, if you have some kind of discipline around documentation, planning, then that's already a huge step ahead of where a lot of people are who just kind of wing it and start seeing their data warehousing costs skyrocket. So generally speaking, our audience kind of tends to fall into 2 buckets, and that's the OLAP side and the OLTP side. So on the source system, there's not much changing, but they're big and complex. They're enterprise. They support enterprise applications. So there's hundreds of tables, relationships between them. And that's where people really take the time to start from scratch, understand their business, define their entities, define exactly what are the interactions between the different domains of their business, and then how that then translates to tables, dimensions, facts. And that tends to stay pretty constant. Whereas on the data warehouse side, on the OLAP side, it's in constant flux. The data is already coming in, and there's so many different source systems, there's so many different relationships, dimensions to conform, that users are usually just seeing the tip of the iceberg. They open a report to see some information, and they say, okay, where is this coming from? How did this get here? And for the users who are a little bit more data savvy, the modern platforms make it easy to get in there and start doing your own analysis, but you have to understand at least where the data is and how to link it. So that's kind of the two big use cases that we advocate. We rarely, I don't want to say rarely, but on the data warehouse side, people aren't going to start doing things from scratch. They're most likely going to reverse engineer the existing model and then flesh out some of the contextual, logical details to help them as well as the business better understand what that physical model represents. And they're surprised a lot of the times to see, once they actually start putting in the work of saying, let's map this to our business model, how much of that is misaligned and where all of these bugs and tickets and rework comes from on the data warehouse side. Because if your model doesn't represent what your business operations are, it's always going to result in users coming back to you and saying, this isn't right. This isn't the right data. This shouldn't happen when this happens. I'm not seeing this transaction that occurred on this day. So it just kind of helps to kind of bring things into alignment. In the end, a data model is, forget about all the technical jargon. It's just a reflection of your business. And if you're just winging it, you're just waiting for some kind of disaster. So that's really where most of it is, in terms of getting it right on the transactional side, getting it right on the data warehouse side.
Yeah, I'm really glad you got a chance to double click and define the data model, because that was going to be the question I'll tee up, because we tend to have a lot of these conversations at a higher level, but stepping down to actually define what a data model is, I think it's an important exercise for businesses to think about, because this could easily get academic when folks think, oh, why are we creating a data model? Why do we need to invest in that? But the way you articulated it as it's a reflection of your business, if you can capture that, I think there's tremendous value in that exercise, and it's not just an academic exercise.
Absolutely. And it tends to happen more on the data warehouse side and kind of like data engineers, cloud data architects, and through no fault of their own. They're just used to getting data ingested into the warehouse. So tables, data, semi-structured, structured is just landing from Fivetran, from Airflow, from external sources. And all that data has already been modeled. It's been created somewhere. It's been given a structure. It's been given a format. So it's very easy to kind of take that side for granted and say, yeah, well, that's already been done for me. I don't need to think about this. But again, how do you know it's been done right? First of all, how do you know that the steps that you're subsequently going to take are also going to be in line with the business understanding of what's coming into your warehouse? Because if all you're seeing is tables, it's very hard to infer the ought from the is. So you just see data, but you don't know what it represents, under what conditions it was created, what it links to. And you're kind of, that's always kind of on, when you hear data teams, data scientists, data ML engineers, they're always kind of on the back foot because they're getting ugly data, missing data, don't know where to find the data, et cetera, because they're working kind of top down and they don't have anything and no line to work off of in terms of saying, or even just being able to take something simple, present it to the business and say, this is what I'm seeing. Does that make sense to you? Does a client actually connect with a supplier before placing an order, or does the order then build a supplier? Things like that, which is just business processes. But on the data side, they, again, as we said earlier, either they're aligned or you're putting out fires trying to align them.
Wow, that's awesome. And thanks for sharing that. I know we're going to jump into the demo here. A lot of folks are always excited about the demo portions of this. But a quick question for you from an industry perspective. Modeling is one thing, but once you go into particular industry, you tend to see common frameworks. The common data framework, or in healthcare, there is a OMAP, ODC, financial industry has things like that to accelerate building those models. Is that something that translates really well into your product, or can you touch on that? Any perspectives on that?
Sure. So we're not industry specific. Models exist, as you just mentioned, within an industry. They exist within a type of design. There's Data Vault, for example, that's very popular right now because it's solving a lot of the issues on the data warehouse side and scalability. And we, in the end, our input and output is DDL. It's structure, it's SQL. So we're not necessarily trying to either pigeonhole or force anyone to use a certain framework. we try to provide as much tools as we can within a framework with templates, with naming standards and things like that. But you're basically free to do whatever you want, because once you start modeling, then you realize there's so many standards, there's so many ways of doing things, and there's so many pre-built ways of kind of, obviously your transactional data in a store is going to be very different from a transactional in like a claims filing type of scenario. So perhaps one day we're going to get standard models for different industries and things like this. But for now, we're just trying to cover as much of the usability and the ease of use to kind of accelerate development, accelerate sharing and discussions and collaboration, include as many database platforms as possible. So we've already released 2 this year. We're working on Google BigQuery as we speak. So we really want to get people up and running and then start adding even more value on top of that.
Yeah, that definitely makes sense, right? You are a database modeling, and databases could be used for any industry. So I could see why you really want to be that agnostic platform where folks can do what they want based on their specific needs. That definitely makes sense. All right, that's a good segue to jump in and actually show the tool. I'm excited to see SQL DBM. I have looked at it in the past. I know there's been a lot of exciting updates, features, and you're going to unpack that for us. Take it away once you're ready.
Sure. For those who don't know, SQL DBM is a SaaS-based tool. So you log into the website, you register with your user, with your team account, and that's it. There's nothing to install. There's no drivers to download, nothing to patch or configure, the way a SaaS tool is supposed to run. Once you're in and registered, everything is hosted on our side. Unlimited projects, unlimited revisions, and every maintenance, every update, every patch we take care of. We usually release at least once a month in terms of big features and then smaller updates for fixes and enhancements. It's just the convenience of being able to log in from any platform, Mac, PC, browser. As long as you have an internet connection, you can log in and you can use SQL DBM. And it makes it very easy then to share. You go to your account, you add a user, and they receive a link right from their inbox, and they can jump right in and start collaborating, whether as a fellow modeler or just a viewer from the business side or project managers. It's one of the things that we've kind of had in mind since the inception. Yes, modeling is a technical process. Data modeling is a technical tool, but there is that business component that we've just spoken about. So how does it make sense to close it off and not allow business users to come in and contribute their half? So we'll see once we dive into some of these projects what that looks like in practice.
All right. And then before we jump in, just more from a higher level perspective, you mentioned it's also cloud-based. Is there the option, and it's okay if the answer is no, is there the option to choose the residency of your platform for maybe compliance reasons, or cloud providers or geographic locations?
Yeah, there is. So it's actually something we're releasing as we speak, literally this week. So we're calling it the Enterprise Plus Compliance and Security for that exact reason. We're going to let you bring your own S3. Initially, it's just going to be S3, but we're going to expand to Azure containers very shortly for that very reason, for residency, for compliance. And this way you can encrypt your own data. You can, when I say data, again, we are a modeling tool, so we don't actually touch data. Everything we do is metadata, which in a lot of cases is still very confidential, very protected in terms of intellectual property, depending on some of our clients. So we want to make sure that's as secure as possible. So if you want to host it on your side, what you're really hosting is the project file of what your tables, relationships are. There's never actually any physical data. So
no profiling that could potentially bring back actual data.
Okay, where I'd like to start is I'd like to start by showing folks how easy it is to get up and running with nothing, from zero, of the typical scenario that we always see of, I have a data warehouse. It was so easy to get started that I just started building, and now I have 500 tables, and some of them are out of date. Others, I don't even know where they are, and it's unusable. So let's create a project. Literally, we'll spend more time talking than actually doing, but
Mm-hmm.
I think within 2 minutes, we'll be up and running, surfing, navigating our data landscape. So let's go ahead and take Snowflake. With our cloud-based data platforms that we support, such as Snowflake, we have the connect direct option, and that's just going to allow us an easier way of getting in and getting the DDL out of our database. Otherwise, you can type it in or upload a file. So with direct connect.
And while you type that out, I just want to make a comment that I do appreciate from a UI perspective, the dark screen mode. You just would not imagine the amount of tools out there that just don't have this option. And I think I do appreciate that. Just a personal comment.
Yeah, data modeling, it's not the sexiest thing in the modern data stack, but at least with this dark mode, you feel a little bit better. So we do have the light theme for those that don't like dark, but it's my preference as well. So yeah, glad you picked up on that. Once we're logged in, so these are my Snowflake databases that I'm permissioned to see in my account. So we can take a look at the different schemas. We can select one or multiple schemas, hit apply. That's just going to select get DDL for all of my objects. You can review this. You can add things. This is just text for now. But once you hit upload, that's where we come in and we begin the work of parsing these into the constituent objects, tables, views, functions, procedures. So here we're kind of just seeing some of the parent objects. So things like file formats are also included, but within, not listed individually. So this is a new project. So by default, there's a couple of diagrams that we create for everyone. And we can, in the process of importing, already start a new diagram, either for the entire schema or separate schemas as we're doing multiple. And let's just auto layout and suggested relationships. This is kind of one of the killer features that we released this year, but we will come back to it manually. Right off the bat, we're looking at a physical model. So all our tables have been read in, and these relationships that we're seeing that tell me, for example, that currency rate uses currency, which is used in the all the way down there on the new fact currency rate and on the fact sales table. Now I'm able to click on any one of these relationships and understand exactly how these things are linked together. So sales territory key linked in the facts reseller sales table. If I'm doing my own ad hoc analysis, I know how to write the joins, I know how to query, I know how to find, there's a search bar, but let's go step by step. The first thing I wanted to mention was exactly what we're looking at. So all of these relationships, these are physical constraints. So in Snowflake, when I say physical constraints, I mean primary keys, foreign keys, unique keys, and there's a huge misconception even within the Snowflake community that Snowflake does not support constraints. And same for Azure Synapse, which actually does not support some constraints. They don't support the foreign key. But most data platforms, they support constraints. What they don't do is cloud data platforms, that is, they don't enforce them. So they don't actually check to make sure that the rules you set out in your constraints, that you're actually following them. You're not loading duplicates. If you load them, it's your problem. While they don't enforce them, it's still a really good idea to use them because you'll be able to, even if you didn't have a modeling tool, you can still run that same get DDL or through the Snowflake UI, view the table structure, and you will see the primary key. So just the primary key alone, forget about relationships. That's going to save you the trouble of saying, okay, what is the unique record here? What is the granularity? So group by having greater than one, how much time are you going to waste on every single table if you need to perform that check manually? So that's one reason. And the other reason is, again, third-party tools like modeling tools, even dashboarding tools. You bring in two tables into Tableau or Looker, they're already going to read the foreign key and say, here's the join. And if you want to modify it, but it saves you not just writing the query. That's the easy part. The hard part is knowing that these two are linked.
Mm-hmm. So this is really cool. So this is, I think what you're showing here is how easy it is to reverse engineer a schema that exists already. Snowflake, and you can begin taking actions and updating and just understanding what's happening with the data model, which essentially is the data behind the scenes. A question for you would be, what are some of the common mistakes you see for folks that are doing modeling? What would be some of the recommendations that you would have around that from a SQL DBM perspective?
Sure. I'm going to start with kind of the most obvious one is not doing data modeling. That's kind of the most common mistake in modeling. So what we've just done, the reverse engineering and being able to draw this diagram, a lot of people come to us and say, yeah, that's great, but I kind of messed up and I didn't do this from day one. So I'm not going to sit there with my 300 tables and draw all of these relationships to even let me get started. So,
or was put it in Excel and try to do all the mappings in there. I've seen folks do that, and trust me, I'm like pulling my hair out because of it.
One of the things that we introduced to get around that was that suggested relationships feature. So this is at least a way for you to wipe the slate clean and get started on the right foot, which is if you haven't declared your primary keys, your foreign keys, you've got just literally like you log into Snowflake and you open up the schema dropdown and you see a list of tables. That's what most people's data models look like. Just a bunch of table names with nothing else. Obviously not very helpful. With suggested relationships, this is actually kind of two features in one, suggesting primary keys, suggesting foreign keys. What we can do, and this is again, without looking at the data, just by you saying my key fields tend to have the word key or PK or code, but I also have a bunch of things like date ID and name and things like that, ETL ID, that are definitely not primary keys. So exclude those. Just off of these naming conventions, we can go and we can scan through this example. Most of the tables have been defined, whereas some have not. We're suggesting that looks like a currency rate has a currency key. Is that correct? Yes. Fact finance has these 5 keys, but actually, let's say scenario key is not part of the primary key, but date key in this case is. So very quickly, you can kind of go through the list, modify, make sure this is something that a data architect would typically do with the business user. So they won't have these answers. This is something that the business has to tell you. How is our information structured? And in a single click, you can create your primary keys. Same for foreign. If you have primary keys, foreign keys are easy. It's just a primary key in one table where it exists in another table. That's your foreign relationship. Very quickly, I can take these and link up the tables that I've missed either intentionally or unintentionally. You can see these are now in a different color, which is because we give users the ability to work with physical keys or virtual keys. So like we said, in Azure Synapse, for example, there are no foreign keys. So users are kind of in a no-win zone in terms of they want to do the right thing, but they just don't have those constraints. So virtual relationships are metadata, so they live in our tool. If you don't want to forward engineer them back to your database, then you create them here, and they feel just like regular physical foreign keys. You can see their related tables thanks to these. This is kind of step one. We've done the minimum. So I will get back to your question. We've done the minimum. We've at least made sure that we've identified our entities. We've identified what is the minimum granularity, what is a single row in our entity represent, how are they related to the other entities. And this is just on the physical side. So one of the things that separates SQL DBM from other modeling tools is we feel that modeling is, as we just said, there's different user profiles, there's different technical backgrounds, there's different ways of looking at your physical data model. How does it look in Snowflake? But it's still related to your business model. So these logical, conceptual All these different, what we call view modes in SQL DBM are always available and working in parallel. So they stay synced. So I can look at, for example, this is still a physical model, but I can flip to keys view as a developer, let's say, since I'm still seeing primary foreign data types, and explore my relationships without the noise of the attributes, for example. Or I can take the same model, go to description. So this is a little bit more conceptual.
If you're presenting to a business audience and you just want to touch on the more conceptual perspective, then this becomes relevant then.
Yeah, exactly. And you can give it some styling, give it some formatting to say, look, these maybe they don't share any relationships, but they belong to the same domain or the same business group. Or even more high level, like totally conceptual box relationship. So even if you're starting, let's say, a whiteboard kind of design, you can still work within the same tool, have all the same suggestions for data types. So even though we're now very abstract, very conceptual, we can still click in, and we didn't convert. All the physical information is still here. So this works in, like I said, in both directions. You could be starting from scratch and filling these in as you go. Maybe some of these by the business requirement haven't yet been defined. So you're just kind of filling them in as they become available, as you're having those conversations, or vice versa of, let's go to, for example, logical. And we can start documenting things that, if we're kind of working backwards like we are here, let's say we have a many-to-many relationship, which now has a bridge table, has the associative table already created since we're coming from a physical model. We can say, well, this is a many-to-many table. So let's make sure that I can identify that. Let's make sure that all of the relationship names like has or owns, let's say owns, are documented. And again, only because I'm going backwards. Otherwise, in a logical mode, we have a many-to-many relationship type. So if let's just find a table somewhere on the outside. So let's say if I was designing from scratch, then I can say, okay, there's a many-to-many relationship between this domain and this one, and this already creates the associative table for you. Because if we flip back to physical, because we're not converting anything, everything happens in parallel, which means all of these features that we once defined, not only do they stay in sync, but you can take advantage of them in any view mode. So if this conceptual logical representation is helpful in viewing your physical diagram, like maybe not the diamond, but definitely the relationship name, not a physical object, but definitely helps me understand the relationship between these two objects, then I can turn it on and off. I can change the notation, crow's foot to idefix on the fly, and just work, as we were saying earlier, at any level with any type of user. Again, go back to your question. Other mistakes that we see is kind of what we were focusing on here, too much on the physical, forgetting that if you're a data architect, you might come in here and you might feel very comfortable saying foreign keys, alternate keys, clustering on a table, and you feel like you're doing modeling, but you haven't added any business users. You haven't checked any of this with the domains. You haven't even opened up the logical view mode and supplied some of these descriptions. That's kind of, if we were to generalize, that's probably the second most biggest deficiency that we tend to see of, let's go ahead and save this, of working in isolation. So this is a very powerful tool, very powerful piece of information that we've just rigged up, as we said, in just a couple of clicks. Why wouldn't I go ahead and say, let's invite Anna. Why wouldn't I take one of my collaborators, one of my team members, or one of my business users and say, hey, check this out. I've just spent, whatever amount of time documenting, filling out descriptions, filling out the relationships. Does this make sense? You're the finance expert or you're the sales expert. Find your tables. In fact, we can even help this user and say, we've already grouped the finance, say, departments, and let's go ahead and create a finance department. And let's start with fact finance. Let's bring all related objects, just kind of working off the top of my head. And very quickly be able to involve users and fact check this and say, this is what's in the system. Does it hold up to the scrutiny of the actual business?
Yeah.
And
The collaborative aspect is always very powerful to have, making data modeling a team sport across different domains on the deep engineers who are actually building the products, and then bringing in the subject matter experts from the business to all participate in one platform. Really powerful to see.
Yeah, absolutely. So, like we said, we started top down, but in an ideal scenario, this is why we're able to go so fast, because technically, a lot of this work has been done. But in a proper modeling use case, you start with nothing. You start with sending a meeting to your business teams and saying, let's talk about it. So, for example, in Kimball's dimensional modeling method, start by identifying the facts, then the dimensions, then, the other way around, dimensions first, facts second, painting that matrix of where do they actually overlap. That kind of starts to form the idea of what are you going to be building towards, then identifying the attributes of each one. And now you're starting to see the data part of the model taking form, whereas the business part has always been there, whether you put it on a diagram or put it in Excel or put it on a napkin. There's no business without an idea and without defining what is a customer, what do we sell, what do we do, what kind of information do we capture. So that's really the key behind everything. Data types and relationships and constraints like that all comes at the end. But the important part is to get the business side right. And you can't do that without involving the business team.
The business. Awesome. Then once you're done with this, you materialize this back to the database to actually create the physical objects within Snowflake per se, if you were building from the ground up.
Exactly. So one of the things that let's jump over to a project that has a little bit more work done on it, or let's go to the dashboard, just so I can demonstrate some of the change tracking and CI/CD options. As we mentioned at the onset, SQL DBM hosts an unlimited amount of your projects. Every project has an unlimited amount of revisions, and revisions are really every time you hit save, you create a version. So this project has 800 changes or versions. So before we get to actually deploying the code, the most immediate implementation of that is being able to see what changed. These are totally additive. I can compare any two and see any changes between as far back and as far forward as I want to go. This way I can kind of see, based on whether it's sprints or changes or tickets or whatever I'm doing, what changed from point A to point B. So within 2 tables have been modified. This one had a column added. We created 2 new tables. We deleted a couple. Now we know what we're about to forward engineer. What are we about to bring back to the database? With SQL DBM, there's a couple of ways to do that. You can just go so we are checking any errors and inconsistencies. We're checking for the naming conventions and case standards, so that it's already been enforced with every save. So we're kind of, we've already checked everything behind the scenes. And now we can either generate
That's a very powerful productivity thing to call out, right? Those naming conventions and standards is things that usually gets teams off. It's one thing to have tables, but if you want to have tables in a consistent naming standard and folks are not doing it correctly, being able to catch that is very powerful.
Yeah. So maybe that's a great point. There's a lot of these things like I take for granted that they're here, you use them, you should use them. But what you just described of, if we're doing, let's say, Pascal case for this database or uppercase or whatever we're doing, if we're adding, let's say, primary keys, we've put a formula, an expression where they contain the table name and the column name. So I don't even have to name them. They're just consistently named with a unique descriptive name. Or, we have a certain prefix or suffix or whatever. with this validate on project save, I don't need to then police anybody and say, are you following these standards that I so carefully set out? Every save will just transform the objects that you're using. So let's go ahead and save that. So once we've done that, we have two ways of, well, actually three ways. Generate SQL. So this is if you're doing a clean deployment, fresh database, you just want the full create statement of every one of these objects, or you can search for whatever you want to deploy individually. Or if you're deploying to an existing database, then alter scripts is what's going to take advantage of those revisions like we just saw earlier. So some of these I can tag with, like, let's say I do my deployments, I put a little star next to it. Now I know that from here onwards are my new changes. Or let's just go a little further back.
So this is useful when you're making changes and adding, say, new columns. You don't necessarily want to drop the entire table in production. You want to just do an alter to add that, the declarative versus the imperative style of database management.
Exactly. So anything new would still come across as, I didn't realize I had that many alters, but anything new would still come across as a create. Any drops in this case would be, or the deletions would be a drop. Alternatively, we can also set up live shortcuts to the environments that we already have. So before we were looking at the history in the project, but we can take advantage of that same functionality between the project and environments. So I can compare project to, let's say, prod. Here I've never done a deployment, so everything's going to look really different. But I can even compare environment to environment and say, are these in sync? So yeah, some tables are, some tables aren't. And I can create that same alter script, whether project to environment, specific to where I'm deploying, and sync them up exactly the same way as we saw earlier.
Okay. So if you've been pushing changes to, say, dev or to stage, and now you're ready to take it to prod, you can compare your stage to your prod, get the diff, and then apply that to prod from an imperative way. Pretty cool. Where is this versioning happening? Are you using your own local versioning system, or this be plugged into Git or Bitbucket or some of those type of?
Great question. So to keep the projects always in sync and consistent, we save the project versioning on our side. So we're hosted on AWS. We store it internally for the user. They don't have to manage anything. But if you see here, this little GitHub button, if you wanted to then also integrate your own Git repository, so this project I linked with GitHub, but you could have used GitLab, AWS, Azure DevOps. We support any online-based Git environment. And that gives you the option to do two things. It's a little clearer if I come back to forward engineering. If I also, so when we looked at compare revisions, that was really the history of the project, changes across the project. If you want to use Git the way most people use Git, which is at the object level, you want to use Git to track history, then by pairing the environment, the repository to the project, you have two options. A source DDL is that traditional way of working with Git. So everything we've just generated here, we can set, what this will do is it'll create a branch, but that branch will contain individual files for every single object we have here. So users.sql, test.sql, you can send them to independent subfolders by object type if you wanted. In fact, you can take a look at what's going where before you hit publish. And this way Git keeps the object history. Whereas the other option is if you wanted to automate these deployments, whether you're doing that between environments or from a previous version of the project, with the migration option, this will create a branch, same thing, but now the branch will contain just one file, and that file will be, it'll be exactly the same contents that you see here, but that file will be named in a naming convention that tools like Schema Change or Flyway will recognize and deploy for you. So these are CI/CD tools. They sit between your Git and your database. So they just listen for changes on a certain branch and then they deploy to a certain environment. So they might be configured, listen to the dev branch, deploy to the dev database, listen for changes for the test branch, deploy to the UAT database. And this way, whatever you do here, you check it, you deploy it. It follows then another round of approvals and acceptance or whatever you have set up at your repository level. If that's okay, then it goes right to your database.
I like that. That's one of the questions coming into this session, wondering how you integrate into the DevOps and the CI/CD pipeline. Thanks for sharing that. Now, for a little bit of a higher level question, how does this, or what are your recommendations in terms of how to evolve or make sure your data model remains relevant as the business evolves over time? Because it's one thing to create the model at a point in time, and the business changes, the macroeconomics changes, the world moves on. How do you see folks keeping this relevant over time?
The most straightforward way to do that is to evolve your model through the same tool that you've been using to track and design it. So this kind of applies more on the OLTP side. So you'd probably be working with SQL DBM to start off with to plan the structure, plan the new tables. But we have plenty of people that said, all I did was click start a trial on your tool. I did my initial reverse engineer. And right off the bat, I found 20 different tables that were redundant, obsolete, still consuming credits because we were loading them for no reason. So that's kind of one, like that's the quick answer. But everything that we did here was, in this demo, just going in reverse, getting up and running. But this reverse engineer feature is not meant to be used once. So specifically as we said, if you're kind of designing from here, then there's nothing else to sync. You've already done the work and you're just deploying it. But on the data warehouse side, I can run this step as many times as I like. So if I log in now, same database, but we're going to notice that once we pick up the objects, some of them are going to already exist, and some of them might be new, modified. So there's actually a new view that somebody created in my database. There's a couple of tables that have updates, or I can say, all of these things that are originally built in development, they don't exist in production, so I actually want to delete them. Once I hit import, this is what's keeping everything in sync. So to me, this is just another revision. If I want to actually see what changed, then I can go to compare revisions and see those tables deleted, tables added, etc. Create any relationships if I needed to. But what you're essentially asking is, just like we said, are you putting in the time to model from the beginning? And are you putting in the time to do proper modeling at the end? We got these tables. Are we going to document them? Are we going to describe their relationships? Are we going to verify them with anyone? Let's say maybe I didn't know what they were, where they came from. So we kind of glossed over all of the documentation piece, the flagging, the governance side. There's a lot of directions that we can go in terms of if it's online, if it's accessible, if it's just there in front of everybody. Why not use it? Why not use it to search for, let's say, do we have anything from Salesforce? Maybe there's no tables, there's no column names with that name, but some business user has come in and filled out a description, a business formula, a piece of logic that now anybody coming in here can find what they're looking
can search. Yeah, almost like a knowledge glossary. This is a good segue to two questions that just came up as you talked about this. One, do you have integrations to traditional data catalogs that typically would scan or harvest that metadata from the data warehouse? But do you see them potentially coming here to your platform to grab that too as well? Because you equally have it, not just the physical description, but also the comments and glossary that has been included. Is that something that you've seen?
Yeah, absolutely. So that's kind of right in line with what we've started out saying of don't do modeling in isolation. So we do provide cataloging features here, some very basic ones, dictionaries, tags, flags. If people want to use something like Elation, Calibra and really go invest the time and the resources that it takes to do cataloging across a big organization.
Mm-hmm.
We just released an API, so you can programmatically query any project or any element of the project and pull out information from our. You can push the post part of that is almost ready as well.
Mm-hmm.
So you can, if you have an integration tool, you can push elements directly into SQL DBM through an API. You can edit this via Excel. So this is kind of a user-friendly Excel. It can't break your project if someone starts editing the relationships or the data types.
Oh, nice.
You can take it, send it to different departments, and when they send it back to you, they don't step on each other's toes. So it only takes the sections that have been added. So if they're separate departments, they fill out separate sections. You upload it back and everything's available here. But the most important thing is, before it goes to any catalog, it'll go back right to the database. So this is not metadata, logical name is, but description isn't. Descriptions are object comments.
Mm-hmm.
So as soon as I fill out anything here, on the next forward engineer, that all goes right back for any tool that can see my database, or any user that's using my database will have this information as well available.
Included in the comments, like in Snowflake, you can add the comment to objects.
Yeah,
makes
exactly.
sense. The last question here around access. How do folks get this? What is the pricing? Is it per object count? Is it per seat? What's the licensing around this for folks who might be looking at trying this out or bringing this to their organizations?
We have an enterprise style licensing model. So we have a couple of tiers, starting from just very basic modeling of just interacting with your database, nothing, no governance, no bells and whistles, like lineage analysis, for example, for views. Like these are premium features that we built for our enterprise plan. So you can kind of like visually, just like we do for tables, also explore views, understand like where a certain column gets created, how does it flow throughout your view column lineage. So these are going to be in the enterprise plan. The integrations with Jira and Confluence are in the enterprise plan, but there's 3 different plans. Well, now that we've added the security one as well, that just kind of gives you the no extra features, just the being able to self-host and self-manage your keys. And we work with users, whatever they need. Most of the people that we tend to, let me put that another way. Most of the new users that we interact with tend to go with some form of the enterprise plan, just because of the convenience that it adds. So you're already a big corporation, you've already got a big data landscape, there's a lot to manage, there's a lot of user profiles. So it's not so much the modeling piece, which is available in basic. It's more the collaboration, the viewers versus modelers, the integration with your Jira, your Confluence, being able to do a diagram, embed it, and have, without adding a single user into the tool, it's now available on a Confluence page where everyone sees the latest version of your projects. For many people, that's really where the value is. It's like, once the data model exists, how do I get it out there? How do I make sure people are seeing it and using it?
That's awesome. Thanks for sharing that. Essentially meet the users where they are based on your needs. If you're just starting off, you need a few features, there is something for you. For more enterprise type folks that need more like the lineage and the more advanced capabilities, there is something for them. As always, we're going to leave all of these links in the description below. I know these demos who are just touching on the surface here. I always encourage folks who have questions to reach out directly to Serge on LinkedIn. We'll leave all the links below. Any last words, Serge, for the audience and the team in terms of where to find you or the platform and the next steps?
Sure. To wrap up, I guess all of this information is on our website. So pricing is here. All the features are described here, comparison between the different plans. And there's also a button here to go ahead and get started. It's free to try. It's web-based, nothing to install. So try it for yourself. The free version is a little bit limited in the features that it provides. So you're not going to get the full enterprise, but that's also, we do have a free trial of enterprise. Just speak to our sales team and they'll enable it for you. But I think we're kind of hammered home the point of why do it, how to do it, how to make sure you're not doing it in a silo and in isolation. And everything else is really get started. There's really no excuse. If you think it's too late, you've already done a bad job from the beginning, it's a couple of clicks away to remove all of that technical debt and stay compliant, stay documented, and just makes everyone's lives easier. Instead of having to go ask questions, write emails, make meetings, it's all at your fingertips.
That's awesome. I think that's a good wrap up to that. Really appreciate having you on the show, having you on the Demo Hub. Again, links to all of this will be in the description below.